Hello, and welcome to Agrosive Physics. Today is day 138, and what I'd like to do today is continue our review of the course. Now for today's lesson, I'd like to look at specifically projectile motion and Newton's laws. And what I have is another assignment of 35 questions for multiple choice, and what I'm going to do is solve those problems and you can check your work. Once again, it's important that you try this assignment first as review and then check your results with this video. And what I'll do is I'll solve all the problems out and we'll talk about the solutions to those 35 questions. This is day 138. Thank you. All right, on to review assignment number 2. All right, question 1. Baseball is dropped from the roof of a tall building. It takes 3.1 seconds to hit the ground. So VI is 0 because it's dropped. T is 3.1 seconds, and A is negative 9.8 meters per second squared. How high is it? D equals VIT plus 1/2 AT squared. This term cancels. We have 1/2 times 9.8 times 3.1 squared. And we end up getting 47 meters, which is choice 3. All right, for number 2, we have a projectile and it's fired at a 60-degree angle. And we got to read this question carefully. It's launched at an angle of 60 compared to the vertical component of the initial velocity. This is the vertical component, so Vy, and then it goes up here and comes down. What is the vertical component at the top? Well, at the top, it's 0. The horizontal component doesn't change, but the vertical component decreases. So 0 is going to be less than whatever the value is, which is choice 1. All right, for number 3. Well, it looks like a spring question snuck into this assignment. But that's good because we need to be able to switch from different topics throughout the course. Now, we're trying to find the energy stored in a spring. And the equation is 1/2 kx squared. 1/2, 30, it's given to us, newtons per meter, 0.5 meters squared. So if we do 0.5 times 30 times 0.5 squared, we get 3.75 joules. And that's choice number 1. All right, number 4. We have a projectile launched at an angle of 60 degrees to the horizontal at 10 meters per second. So we have 60 degrees here, 10 meters per second. What's the vertical component of its initial velocity? So we have x and y. The y component is 10 meters per second times the sine of 60. Sine of 60 is 0.866, so that's 8.66 meters per second, which is rounded to 8.7. All right, number 5. Net force is applied horizontally to a 10-kilogram block resting on a table. So if we draw a free body diagram, 25 newtons, it's 10 kilograms. What's the acceleration? Well, this is strictly an F equals ma. 25 newtons equals 10 times A. 25 divided by 10 is 2.5 meters per second squared. Choice 4. And 6. All right, we have a cliff, and we're firing an object horizontally, and it's flying through the air and landing at distance d. We have h, and it says to use g as gravity. What's the total time of flight in terms of the vertical distance? So we're going to look at the y only. So vi in the y is 0, a is g, we're calling it, and distance is h. So I'm going to use d equals vit plus 1/2 at squared. H equals, this is gone, 1/2 gt squared. Bring the half over and divide by g, so it's 2h over g equals t squared. Take the square root. We have 2h over g, square root of 2h over g, which is choice 1. Choice 4 is very similar, so you have to watch out for that. 2h over g is our choice. All right, number 7. An object is thrown horizontally off of a cliff with an initial velocity of 5 meters per second. So we have a cliff, 5 meters per second. Object strikes the ground 3 seconds later. How far from the base of the cliff does it land? If we remember the x direction, we have constant velocity. Gravity only acts in the vertical direction. So basically, if we project it at 5, it stays that way. So you're just going to do v equals d over t. 5 meters per second equals d over 3 seconds. 5 times 3, 15 meters away. Choice 3. All right, number 8. Child kicks a ball. We have an angle, 35 degrees. We have 4.9 in the y. We have 8.5 on the diagonal. And we want to find the horizontal component. So it's going to be 8.5 cos 35. 8.5 cos 35, 6.96 meters per second, which they round to 7. So 3, choice 3. All right, number 9. Quite wordy. So we have a net force on a planet and small discrepancy between the calculated orbit allowed us to find the planet Neptune. We have a chart of data, so we have a data table, and we have to read through the data and answer. Magnitude of the force of the sun exerting on Uranus is 1.41 times 10 to the 21 newtons. How is it possible for the sun to exert a greater force on Uranus than Neptune? So the force of the sun is greater than the force of Neptune. Okay. So why is the sun stronger than Neptune? Well, we know that F equals big G mm over r squared. And from our data, the sun is closer than Neptune. Well, that's not true. The sun's farther. So 1's out. Neptune has more mass. Mass of Neptune is bigger. Okay, so 2's possible. Neptune has more mass. Uranus has more mass than Neptune. According to the chart, that's not true, so 3 is out. So then that means 4 is possible also. Let's say Sun has a greater mass than Uranus. Now, which one is more likely? The bigger mass of the planet or the bigger mass of the Sun? Well, the Sun has a mass of 10 to the 30 kilograms. So that is one that is much more important than the mass of the other object, because we're talking about 10 to the 25 and 10 to the 26 versus 10 to the 30. 4 zeros more. So the best choice is going to be choice 4, Sun's mass. Number 10. All right, we have a diagram. There's a 4 kilogram block, and we have an 8 Newton force acting on it. What's the acceleration? Well, F equals ma. 8 newtons, 4 kilograms, times A. A is 2 meters per second squared. So, choice 2. And 11, we have a force of 50 newtons, and we have an acceleration of 10 meters per second squared. F equals ma. 50 newtons, m, 10. 50 divided by 10, mass is 5, which is choice 3. All right, for number 12, we have a graph of range versus angle. And it looks like this. And this is 0 angle, this is 90. and this is 45. And the graph shows that the range of projectiles is the same for all angles. So no, it's not a flat line. Same for 20 and 80. If we look, 20's here, 80's here, so they're not the same height. Greatest for 45, that is true. Greatest for 90, well, it's the lowest for 90. So we're going to go with 45. Greatest at 45, which is choice 3. All right, 13. We have a block. We have 3 newtons to the right. We have 8 newtons to the left, and it's a 2 kilogram block. So the net force is going to be to the left. It's going to be 5 newtons equals 2 kilograms times A. 5 divided by 2. 2.5 meters per second squared. And it's to the left because that one wins. So, choice 2. And 14. We're kicking a soccer ball. It's 5 meters per second, 30 degrees. Ball's initial velocity of 5. What is the magnitude of the horizontal component? So that's going to be the cosine. 5 meters per second, cos 30. 5 times cos 30 is 4.33 meters per second, and that's choice 2. Number 15. During a collision, an 84 kilogram driver of a car, so mass is 84, and it's moving at 24 meters per second, and it's stopped, so VF is 0, and the time is 1.2 seconds. What's the magnitude of the force? Well, F equals ma. Mass is 84. To find acceleration, I'll use this equation and do equation 3. VF equals VI plus AT. So 24 divided by 1.2 gets me 20. That's a negative 20. So 20 meters per second squared. We'll worry about direction later. 84 kilograms. So 20 times 84 is 1680 newtons. 1680. And they're listing everything in scientific notation. So let me change that to 1.7 times 10 to the 123 newtons. And that matches choice 3. All right, 16. Diagram shows a person throwing a ball off of a cliff. We have 25 meters per second. The height is 45. How far from the cliff will the ball hit? All right. So we want to find D. Now, first we need to find how long it takes. So the Y, which is VI is 0, A is negative 9.8, and D is negative 45. So equation 4, so D 45 divided by 0.5 divided by 9.8 square root. So time is 3 seconds. And then in the x direction, it's V equals D over T. So 25 times 3 should be around 75 meters. And that's choice 2. All right, 17. Student and the wax skis he is wearing have a combined weight of 850 newtons. Skier travels down a snow-covered hill, glides to east along a snow-covered horizontal surface. What is the magnitude of the force of friction as the skier glides across the snow-covered horizontal surface? So, total weight, 850, meaning total normal force, 850. Friction is mu Fn. Well, we need to know what mu is. So if we look on our chart, wax skis on snow is 0.05. 850 times 0.05, 42.5. I guess closest one is 40. So 0.05, 850, 42.5, and we're going to go with 40 newtons. All right, 18. We have 4 projectiles and we have a chart of information. So, what projectile traveled the greatest horizontal distance? Now, what we need to worry about is Vx and t. And we're going to do d equals vt for each. So, horizontal speed is 40, time of flight is 6. So 40 times 6 is for A. 60 times 4 is for B. 50 times 5 is for C. And then 80 times 4 is for D. Now 6 times 40 is 240. 60 times 4 is 240. 250. 8 times 4 is 32, so 320. So that would be choice D, which is number 4. All right, what graph best represents the relationship between masses and the gravitational force acting on them near the Earth's surface? And we have graphs that are direct, no relationship, square root, and a direct squared. So how is force and mass related near the Earth's surface? Now remember, this is 9.8 all the time, so it's G. So force divided by mass, it's a direct relationship. It's got to be choice 4. Shows this, force, mass, direct relationship. And now for 20. Graph shows a relationship between weight and mass for a series of objects on the moon. We have weight and mass, Wm, which is the same as force of gravity. Force of gravity is mass times acceleration. If we divide, the acceleration is force of gravity over mass, which is the slope. Now what I can do is just take 32, because the 0 and 0, I'll take the endpoint, 32 over 20, and I'm going to get 32 divided by 20. I get 1.6 meters per second squared. And that is the acceleration of gravity, 1.63 is, of the moon. So maybe we just knew what the acceleration of gravity on the moon was and skipped the work. But it's good to verify because I know that it's 1.63. 21. 60-kilogram astronaut weighs 96 newtons on the moon. What's the acceleration of gravity? Well, we know it's 1.63. But, just to verify, F equals ma. 96 newtons, 60 kilograms, 96 over 60, 1.6, which is choice 2. 22. What's the magnitude of the force needed to keep a 60 Newton rubber block moving across level, dry asphalt? So we're going to need our reference table. Rubber on asphalt, dry, 0.67 is mu. And it is a 60 Newton rubber block, so that means that's the weight. 60 newtons, 60 newtons. So, mu Fn, 0.67 times 60. 40.2 newtons. And it has to be a constant speed, so we're going to use the 40, because then it'll be a constant speed, no acceleration. So choice 1. All right, 23. A projectile is fired from a gun near the surface of the Earth. The initial velocity has a vertical component of 98, horizontal of 49. How long will it take to reach the highest point? We're going to look at the vertical. So VI was 98. VF is 0. A is negative 9.8. Find T. So I'm going to do VF equals VI plus AT. 98 divided by 9.8. T is 10 seconds. Choice 2. And 24. Earth and Moon are separated by a distance of 3.84 times 10 to the 8 meters. Gravitational force of attraction is 2 times 10 to the 20. What would be the magnitude of the gravitational force if the Moon were separated by a distance of 1.92 times 10 to the 8? So 3.84 E8 divided by 1.92 E8 is 2. So what I'm going to actually do is go from double the distance to half. So I'm going to half the distance. And what happens to the force when I half the distance? Well, we need to know the equation is big G mm over r squared. So if we bring the Moon closer, what happens to gravity? So if we do a half squared on the bottom, G stays the same, mass stays the same, mass stays the same. R is 1/2 squared. The force is 4 times bigger. So I'm going to take the original number, which is 2 times 10 to the 20, times 4. 2E20 times 4 is 8E20. And that is choice 4. All right, 25. Acceleration of gravity on planet X is 19.6 meters per second squared. We have the weight is 980 newtons. What's the mass? All right, F equals ma. 980 divided by 19.6, I get 50 kilograms. Choice 1. 26. Centers of two 15-kilogram spheres are separated by 3 meters. What's the gravitational force between them? So we're using the big G equation, mm over r squared. So 6.67 E negative 11 times 15 times 15 equals divided by 3 squared. The answer is 1.7 times 10 to the negative 9 newtons. 1.67 times 10 to the negative 9 newtons is choice 3. All right, 27. Projectile is launched at an angle of 60, and the initial velocity is 40. So we have this is 60, this is 40. Projectile reaches its highest altitude at point P and strikes the target point T. What's the vertical component of the initial speed? So I'm just looking at y here, which is going to be 40 sine 60. 40 times sine 60, 34.6. 34.6 looks like 35. Yep, choice 1. And then 28. We have a ball projected horizontally, shown in the diagram, and then the problem goes on the next page. What represents the position of the ball at 1 second intervals? So this is asking what shape does an object take as it falls? And it looks like the only one that matches what I just drew is choice 4. All right, 29. We have an automobile striking an insect. The insect is accelerated, so it's going to be F equals ma. And the force on the insect is going to be based on the mass of the insect. So 1 times 10 to the negative 4 times the acceleration of the insect. 1 times 10 to the 2. So 1e negative 4 times 1e2 is 0.01 newtons. Now, if the insect applies a force, the car applies a force to the insect applies an equal and opposite force to the car, which is Newton's third law. So the force that the insect exerts on the car is, they're all in scientific notation, so it's going to be 1 times 10 to the negative 2 newtons. So that's choice 1. Number 30. Object is thrown horizontally with a speed of 5 meters per second, strikes the ground 3 seconds later. What's the vertical speed of the object as it reaches the ground? So I'm going to look at the y final velocity. That's what I'm looking for. Horizontally, it was 5, but initially in the y, it's 0. A is negative 9.8, and t is 3 seconds. So Vf equals Vi plus At. 9.8 times 3, 29.4 meters per second. Velocity would be negative, but it asks for speed. So 29.2. Now 31. Astronaut travels from the surface of the Earth to 4 times away from the center of the Earth. Does the mass decrease? No, mass is constant. Mass remains the same. Probably our answer. Weight increases. Well, the weight will go down as you get farther, so that's out. And the weight remains the same. Nope, it goes down. So the mass remains the same. Choice 2. All right, 32. 15 kilogram mass weighs 60 newtons on planet X. So F equals ma. 15 kilograms. A, 60 newtons. So acceleration is 4 meters per second squared. Mass is allowed to fall freely. After 6 seconds, what's the acceleration? Well, acceleration doesn't change. So it stays as 4. So the choice is 4. All right, 33. We have a 10 Newton force to the right and a 6 Newton force to the left. What additional force will establish equilibrium? Well, how do I cancel out the 10? Apply another 4 newtons to the left, and that is choice 4. 34. 3 kilogram mass weighs 15 newtons. What's the acceleration of gravity at this point? Well, F equals ma. 3 is the kilograms. 15 newtons. A. 15 divided by 3 is 5 meters per second squared. Choice 3. And then finally 35. Weight of an object determined at 5 distances from the center of the Earth. What's the mass of the object? So we have the distance, we have the weight. We want to find the mass. So I'm going to use the big G equation. I'm just going to use the first data point, 1,000 newtons, 6.67 e negative 11. Mass of the Earth on the reference table, 6e24 times m over, and for the first data point, it's 6.37 times 10 to the 6 squared. You notice part ones, I don't always use units. Part ones, you're not going to be checked for substitution with units. So what I'm going to do first is multiply 1,000 times 6.37 e negative 11, e6 squared. That's cross multiplying these two. And then I divide that answer by big G, 6.67 e negative 11. And then I divide again by the mass of the Earth, 6e24. And the mass is 101.4 kilograms. So which one's closest? 100, which is choice 3.